So far, we've measured the goodness of our system using one number. But if we want to improve our recognizer, we need to understand what it does good and what not. Like, can it recognize pencils better than houses, for example? A good tool for understanding this is the confusion matrix, a table that says how many items are misclassified as something else. Like here, out of 343 trees, 211 are correctly recognized. But 3 are classified as cars, 1 as a fish, 45 as a house, and so on. Now, let's learn how to code this new visualizer. And don't worry, you won't be confused for long. Get it? Because we're gonna implement the confusion matrix. And no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
We will draw the confusion matrix on top of this chart somehow, and there will be a button here to toggle it on or off, so we can still see the chart sometimes. Let's go to Viewer HTML, where we have our chart container, and I'm going to open it up like this and add a container for the confusion matrix here. So this will be a simple div, just like this one, but it will be called confusion container. Let's give this a style, and I will go in styles CSS. Let's look for our chart container and put this one underneath because they're related. And type confusion container. The position will be absolute, and I want it to be far right as possible, so right 0, and let's give this a white background color, and I want a z-index of 1. The chart has now there some additional items, and I want it to be on top of those. Let's save this and go back to Viewer HTML and add a button to toggle this output as well. So this we will refer to as the output, what is on the right. And now the toggle input function is in JS display.js at the very bottom here. I'm going to copy it and make a similar one for toggle output. And this one is going to use the confusion container instead of this input container. So confusion container here. And we don't need anything else than doing this styling right here. Let's refresh. And here's the button. And when we press it, nothing really happens. But if we open the console here and inspect this element, we can see that this confusion container is actually there. It's just empty, so it has 0, 0 width and height. If we would force it to have here maybe a width of 500 pixels and a height of 500 pixels, then it's now going to cover the chart perfectly. And toggling it seems to work. Let's implement this component next. We will make this component very similar to the chart component here. It's just going to work something like confusion is a new confusion. And here we pass the container the same way that we passed the container for the chart. And then we also need to pass here the testing samples. And we will also need to pass all the classes here. So in order, they are car, fish, house, tree, bicycle, guitar, pencil, clock. And I just realized that we don't have these defined anywhere really. So let's cut this from here and add these to utils. So utils classes. And now here in common utils at the top. We have these styles that contain them somehow, but it's convenient to have them listed as well. So utils classes is equal to what I just copied from there. And back to viewer HTML, I will also pass these options to the confusion matrix component as well. Okay, now we define this confusion in another file. So let's go up here next to the other chart elements. I will also put it inside of the chart folder. So let's put here confusion.js. Inside of the chart here, I will create a new file, confusion.js. And here we begin to type this new class. So class confusion. And in the constructor, the first thing is the container, followed by the samples. We will be passing the testing samples here, and the classes list, and then these options. Let's store these as attributes. So first the samples, then the classes, and I'm gonna take out the size and the style from the options. It's really what we need here. Now the matrix inside there will be an 8 times 8 matrix, but I will actually make it 9 times 9 because I want it to include the header section on the top and another kind of header section on the left. Those would have cumulative values on the columns and rows respectively. So a size for this matrix, let's say n, is going to be equal to the length of the classes, how many classes there are, plus 1. And now imagine the space here divided as a grid of 10 by 10 cells. We'll use the leftmost and the topmost for the labels, and then the matrix will go in the remaining space. So the cell size that we're looking for can be calculated here like so. We need to add another more 1 to that n for it to be proper. We'll display this confusion matrix as a table, so let's create a table element using the create element and passing table here. And now I'm going to pass here a style. We will collapse the borders. Borders make things very confusing to me at least, and we just don't need them. It's gonna be quite nice looking without, you'll see. And everything will be also aligned to center, all the text elements. And because I want to keep space for those labels on the left and on the top, I'm going to also add here a margin left of the cell size, like so. And the same goes for margin top. Now we also need to append this table to the container. And now this table is going to be the holder of the matrix. We need to prepare the matrix and fill the table. So these are going to be 2 private methods. Let's get the matrix ready from the samples and then fill the table like so. The matrix will be an attribute here, so we'll have access to it. This prepare matrix function is going to start off with an empty matrix. So let's define it as an empty list like this. But we will have to generate its rows as well, n different rows. Each of them is going to be an empty list. And each row will be filled with n zeros for now. So I'm going to generate this matrix filled with zeros, like so. And now we can start putting here the values coming from the samples. So let's loop through the samples. I'm going to name each sample S because it's shorter, and the next line is going to be quite long. So the matrix of, and now I want to get the index of the true value of that sample. So the index relative to this classes up here. I'm going to type classes index of the true value of the sample, because those are going to be vertically. And because the leftmost column will do something special and have some cumulative values, I want to go past that. So I add here 1. And the second index is going to be the same, but with s dot label, which is the label we predicted using our machine learning system. And also the top header means shifting here by 1 as well. We take that value of the matrix at these indices and we increase it. And that's it. Now we just have to return here this matrix, like so. And it will be passed to this attribute. Now the fill table method here is going to add the rows and cells into that table. So let's define it like so. And because I don't want to type this all the time, I'm going to use this destructuring assignment here, and I will take out some of the attributes from this. And now I can just use them by typing them as such. We will loop from 0 to n, like this, and generate a new row in the matrix. This row we generate with the create element, and we use the tr element for table row. And let's append this to the table. And now we can loop again. So now we are going to go through each individual cells and create those. These cells are going to be create element. A TD element is for creating the cells. And let's style this cell so that it has cell size pixels in width. And I'm going to copy this or the height as well. And let's remove the padding also. And now I'm going to add the text of this cell to be the value of the matrix at I and j. Simple as that. We just have to add the cell to the row now, and we can save, refresh, and this looks as expected. These 0 values we'll have to take care of, but I also want to take care of this top text here and the left text here. Let's begin with that. So at the top, after we create this table, I'm going to add to the container 2 more things. So let's generate a div for this top text, like so. And this is going to be saying predicted class, and we'll style it to have an absolute positioning and give it a really large font, extra large. Let's set the top value to 0 pixels, and I'm going to position it 50% from the left, but that's going to position its top left corner 50% from the left. So I'm also going to translate it by minus 50% horizontally. And let's append this to the container. Now if I'm going to refresh, It's almost good. I would like it to be lower like this if possible. So I'm going to give this a height equal to the cell size, and then I'm going to use flex positioning here to align to center. So let's go here and give the height of cell size in pixels and set the display to flex and the align items center. Okay, much better. But I would like this to be in the middle of this right here. So this should be the middle point. And that means I need to add it a margin of half the cell size to the left. So let's go here and say that. Great, now we need to do the same for the left text. So let me just copy everything here. And I'm gonna rename this to left text. And the differences are, this is gonna be the label for true class. And I want this text to be rotated by minus 90 degrees. And here, left and top should be switched. So let's move this top here and this left value here. Now we refresh. Looks good. Let's calculate these cumulative values here by adding everything in this way and everything in that way. I'm going to go, after we prepare the matrix here at the end of this prepare matrix, and now we have those values, the ones that we see here in this bottom right corner, and I'm going to use them to add to the 0 values on the left here and at the top. So we do that with a for loop, like so, going through all the elements but skipping the 0th row, and another for loop going through all the elements of each row but skipping the first column, so starting at 1 instead of 0. And here we set the matrix of 0 and j to be increased by matrix of I and j. And the same for the first column also. Let's refresh. And these seem to be just right. This looks like a very small value here, and these all here seem to be small values. None of them is over 100. So I think this calculation is correct. Now these numbers here is what I would expect to get. These values should match these values here if we would do a perfect prediction. And if a value is bigger, like for example this 466 here is much bigger than this 343, or 537 here, it's much bigger than 339, then we are generating too many of these items. If it's too small, then we are generating too few of these items. So I would actually like to see these at the top as a kind of a relative difference to this. Let's do that also with the for loop going through all of the items at the top. I'm going to modify them now that they exist by subtracting the value at I and 0, basically the value on the left there. Refresh. And now you read these as here we have too many, there is an excess, and here we have too few, there should be more of this item. I think that I would like to see a plus sign there for those particular cases. And And also this 0 here is useless and it should be removed. So let's do that. I'm going to set here matrix 0, 0 to nothing. And here, if the value is greater than 0, add a plus in front of it. I'm styling these just the way I like. If you want to do it differently, then feel free. But I'm quite happy with what the end result is going to be. You'll see. Okay, good. But we don't really know what these objects are supposed to be. We can probably remember the car, fish, house, tree, bicycle, guitar, pencil, clock, but better if we show the icons and they are part of the styles. So I'm going to go here and style these cells even more, but only if it's the top row and skipping the first item there in that corner. So if I is 0 and j is greater than 0, let's give this cell a background image. And I will set this to a URL coming from this place. So the styles are going to contain for each class the image, and I will take the source of that image and pass it to this URL. Now here we need to do a j-1 because our j's increase by 1 because of that first column header. And let's close this here, like so. Now I'm going to save this file, refresh, and we should see on the top row what the items are, but these background images repeat now unnecessarily. So let's go here and say background repeat, set it to no repeat. And now let's align these to center, and I also want to give them a little bit spacing from the top there. So let's type here background position 50 from the left and let's say 20 from the. Okay, and let's move now the text lower. So I'm gonna align it vertically to bottom. And let's make it bold as well to be emphasized as a header. Okay, good. And I want to apply the same style also here on this side. So let's just copy this below and replace here I with j and j with I, and here j with I as well. Now this is good. But these values here, the plus and minus, I would like to emphasize them using colors as well. It's hard when looking at so many numbers otherwise. So let's have these positive values red and the negative values blue, kind of like a temperature scale. I'm going to go up here. The color intensity is really going to depend on those values from the left. So we could take out this as a proportion matrix of ij divided by matrix of jy, like so. And let's set the value for red. If p is greater than 0, then I'm just going to take p and multiply it by 255. That's the maximum of the red that you can get. And here 0 red otherwise. And blue is going to be the same, but looking in the negative. And I can't give it a blue intensity that is negative. I have to put here minus p times 255 or 0. And with these, I'm going to set the style color of the cell using this RGB A, like so. Actually, I don't think we need this A at the end, so just RGB. I was thinking to use the alpha as well, but I think that this is going to look just fine. Let's refresh. And you can see some kind of color here. But to get here maximum red or here maximum blue, these differences would need to be really, really big. And they are not. Like, this should be double 339, so 600 something. And even at our current situation with this low accuracy, it doesn't appear so strong. So I'm going to go here and multiply this p-value by 2. And that's going to make it more striking when there is a considerable high value here. And this looks good, I think. Now, the next step is going to be to give these cells in the middle a background color, also depending on their value. And I'm going to use linear interpolation here and give them some values in between the minimum value that we see here and the maximum value that we see here. You can also use 0 and the maximum value. It's up to you, really. But let's first take out all of these values from our matrix and find out those extremes. I'm going to go here at the top of fill table and write the values that we're interested in. We take them from the matrix. I'm going to slice the matrix from 1 so that we skip the first row entirely. And then we are going to take just the items inside by slicing from 1 so that we skip also the first element on the left. And I'm going to flatten these so that all of the values are in one long array. And from these, I can easily calculate now the minimum using the math minimum function. I just have to spread this values array like so. And let's do the same here for max using the max function. So now we know the range where we want to do this polar scale in between, and we can calculate the value in between this range using the inverse lerp function, the inverse linear interpolation function that we defined some time ago. I do have a video on that interpolation concept if you want to learn more. But basically here, if we are inside of the matrix so that we're not in the header section, so if these are positive, I'm going to get this p-value using this inverse lerp between minimum and maximum from the matrix of I and j value that we are currently displaying. And I'm going to set the background of the cell here using RGBA. So 255 for red, and let's put 0 and 0 for green and blue. And the alpha is going to be this p-value, which is going to be between 0 and 1, depending on how far it is from mean, between min and max. So this inverse lerp function is a really simple function here. Given an interval a and b and a value inside the interval, it first subtracts from the value a and then divides by this difference. So you get a result between 0 and 1 depending on this difference. Back here, let's save the file and refresh the page. And this is how it looks like. It's really easy to tell what we are seeing here. Like, many houses are classified as clocks, which is a bad thing. But here, many trees are classified as trees. This is a good thing. So one thing that I would still like to emphasize is that anything on this diagonal is a good thing, because it means that the item is classified as itself. And let's change the color for that as the final update here. So let's say if I is equal to j, so if we are on the diagonal, I'm going to have this, let's copy it. And here, let's close this curly brace, else. I paste this again inside, close the curly brace, and for the diagonal, let's replace here this red, green, blue with 255 and set this one to 0. So this is going to be blue. And again, the transparency is controlled by the same thing. Let's save this and refresh, and we're done with the confusion matrix. And some things here are kind of obvious, like the house could be classified as a clock. I can accept that because we are now just looking at this bounding box there and the aspect ratio, so it doesn't really matter what's inside. But some things here are really strange, like why so many pencils are classified as clocks. This makes no sense. I mean, pencils and clocks look nothing similar, even if you look at the bounding box. Let's close this output and try to figure out what happens here. And if we go here, this is really a mess. I don't see anything useful here with so many things displayed there. What we can do is tell the chart to display fewer items, maybe just the pencils that are labeled as clocks. So these are very easy things to do. We just go to the viewer here, where we have our testing samples that we pass to the chart, and we can filter them. So let's filter these testing samples so that each sample is going to be kept if it is a pencil, but it's labeled as a clock. Now I'm teaching you this not just for the demonstration now, but also that you can inspect your data like this quite efficiently. And if I refresh here and close this output, all we see now is the pencils. And these are pencils that are within this gray region in our decision boundary plot. So they are labeled as clocks. But now we can click on them. Okay. They are probably all drawn at an angle like this. So that means that the aspect ratio is pretty much comparable to a clock. Most likely all of these pencils here are drawn at this kind of 45-degree angle. I actually thought that pencils are very easy to classify because they were so clearly visible inside of this magenta region. Let's actually see here, like if I remove here this filter and refresh, toggle this output, it's like nothing else is there blocking them. But what I understand now, because of this confusion matrix, is that there are actually a lot of pencils there in the middle. We just don't see them because this visualization is so crowded. We could see them if I add my filter back here and remove this part. It's gonna keep just those things that should be pencils. And let's see where they appear now. Pretty much everywhere. And since we are not drawing everything, including Herminio's house, which is somewhere there, it means that our decision boundary plot is scaled in a nicer way. These pencils here seem to have a square aspect ratio inside of this feature space.